Now I want to turn back to the MaxScript language itself and round out some of the things that I introduced earlier. In particular, I will describe the rest of the MaxScript control structures and then look at some additional context prefixes that mirror the other main mode controls in the Max UI.
First, the while loop. I introduced the while loop in the step camera example earlier. It's a repeating loop controlled by a conditional expression and has the general form you see here. The reserved word while, followed by a conditional expression, followed by do, followed by the body to be repeated. This kind of loop is useful if you've got a true or false expression that controls the loop repetition, rather than a collection of values or range of numbers to run through, as in a for loop. Here's another short example of a while loop. Inside a function that takes a scene object and generates a text string containing that object's full path name. Let's try it first. Here again is the simple skeleton scene I used in the original path name explanation, containing a body with a node hierarchy going from the torso and down through each extremity. I'll select the left toe down here and then call the function on it. Remember, the $sign is the way to get at the current scene selection in MaxScript. It returns a string containing the toe's full path name down through the linked scene hierarchy. Okay, let's look more closely at the code. The function definition takes a single parameter, the object whose path name we want to construct. Essentially, it starts at this object and loops back out through the hierarchy following the .parent links, grabbing each parent name and building the path name backwards, one level at a time. First, I declare a local variable pn to hold the accumulating path name and initialize it to the current object's name. The loop starts out with the parameter variable obj containing the original object. Then on each loop, updates the variable obj to contain the parent of the object that is currently an obj, and keeps doing this until it hits the top-level object. A top-level object, that is one with no parent itself, has the special value undefined in its .parent property, and so this becomes the loop condition. While the .parent of the current object is not undefined, repeat the loop. The loop body updates the variable obj to contain the current object's parent, and then sticks the parent's name and a / character on the front of the accumulating path name. The loop then repeats, this time on that parent, looking to see if it has a parent, and so on up the .parent links. The final expression here sticks a $sign in front of the path string, and being the last expression in the function body, is returned as that function's value. Let's now explore loop control. All the loops support special commands for controlling the loop from within the body. For example, the continue command tells a loop to stop evaluating the rest of the body for that iteration and to continue from the beginning of the next loop. Here's an example. This script is looping over the current scene selection, calculating some mesh stats for the objects in the selection. The if statement here is filtering out non-mesh objects using the built-in isKindOf function, which tells you if an object is a member of a given class or inherits from that class at some level. If the current object in the loop variable is not an instance of or descendant of the editable mesh class, the then branch is executed. This throws up a warning message dialog saying the script is going to skip the object, and then uses the continue command to skip the rest of the loop body and immediately continue with the next iteration. If the current object in the loop variable is in fact an editable mesh, the then branch is not executed, and the stats accumulation code down here is run, which, as you can see, is adding some counts to some stats variables. So let's try it on this scene. I'll select all the objects and evaluate it. And you see we get the warning dialog for the circle object, which of course isn't a mesh. The warning message dialog is displayed by calling the built-in function messageBox, which takes the text string supplied as its parameter. The message string being displayed is constructed in the previous line here, using the plus operator on strings to build up the message. This concatenated string is placed in a local variable, which is given as the parameter to the messageBox function. You can also cause a loop to terminate prematurely using the exit command.
You might use this if the code inside the loop detects an anomalous situation or hits some limit and needs to terminate the loop early. It's also commonly used when searching through a sequence or set of things to find something.
For example, here I have a scene with two animated balls in it and a particle system. The balls swing towards one another and then away, and I want to find exactly the frame at which they are closest to one another, and then set the particle system start time to that frame, and position the particle system midway between the balls at that point. So here is a script to do this. Basically, it runs through all the frames, computing the distance each time, and comparing that to the distance in the previous frame. As the balls swing towards one another, the distance at each frame will keep getting smaller. But as soon as they pass the closest point, the distances will start increasing. So the loop detects the frame at which the distance starts to increase and stops itself at that frame. First, I declare some local variables. One to hold the closest frame number when the search is successful, and another to hold the previous frame's distance at each frame during the search, which is initialized to the time 0 distance between ball 1 and ball 2. The loop then sets itself to run over the entire animation range, beginning at frame 1, so we start out comparing frame 1 to frame 0. The distance test is embedded in an at-time context, so the object positions are always computed at the loop time. The distance between the two balls at the current loop time is grabbed into a local variable and compared to the previous frame's distance here. If it's less than or equal, the balls are still moving towards one another, and so the search should continue. And I set things up for the next loop by updating the previous distance variable with this loop's distance and loop to the next frame. If the distance in this frame is greater than the distance in the previous frame, the balls have just started moving apart. So the result variable is assigned the prior frame, since it's the actual closest frame, and I use the exit directive to stop the search loop. Following the loop, the particle system is positioned midway between the balls at that frame, and the start time is set to that frame. Okay, so let's run it. And you see the particle system has been repositioned, and it fires at the right time. You can also use the function return statement to break out of a loop. Here's an example. The findByUserProp function is useful in scenes where user properties have been added to objects, say through the Object Properties dialog. It can find an object in the scene with a given value in a particular user property and is a classic example of a search function. It takes two parameters, the user property to search and the value to search for. The for statement loops over all the objects in the scene, calling the built-in function getUserProp on each object to extract the named property. If the value of that user property in the current loop object equals the supplied value to search for, we've found the desired object, and the return statement is executed, breaking out of the loop and returning the current loop object as the result of the function. If a match is not found in all of the objects in the scene, the function returns the value undefined.